all of the Egyptian sciences and arts seem to have been in place at the very beginnings of Egypt. Upon examination, we find that rather than primitive fumbling, the Egyptians were using a method of calculation precisely like our modern computers.
The prevailing narrative of the history of mathematics is that it started with the Sumerians and matured with the Greeks, with some contributions from the Arabs and the Indians. But historians now show that the Africans, who are missing from this narrative, turn out to be the pioneers and the most influential when it comes to the chronicle of mathematics, from 20,000 BC to 1900 AD. From the invention of our numbers system and its notation, to basic arithmetic, prime numbers, to geometry and algebra, to trigonometry, fractions, fractals, recursion, to standards of measurement, and binary code. Including the Greeks, many nations have contributed to the advancement of mathematics as we know it today. However, particularly decisive are the contributions of the Africans to this science. They have been all too often overlooked or wrongly attributed to other civilizations. And yet, the historical evidence points to a very long African mathematical tradition, one that kick-started the science itself, spread it to the four corners of the globe, and gave us the pillars of our modern math. Accurate method of investigation of the knowledge of all existing things and all obscure secrets and mysteries. That is the definition that the ancient Egyptians gave to the science of mathematics. In fact, the word mathematics itself comes from Maat, the goddess of balance, coupled with the Egyptian word for science and inquiry. In sum, mathematics really originates from the study of the mysteries that lead to balance, to Maat. The historical evidence on this is too numerous to cite in one video, so I will leave a booklet of sources in the description for those of you who like to dig deeper. And you can always contact me on Twitter for more detailed discussions. By the way, the ancient Egyptians were not the only Africans to pioneer revolutionary math concepts that have changed the world as we know it. We will review many of them so as to get a good understanding of how the Africans thought of this most exact science, a science which, for them, accounted for everything, from zero to infinity, and they devised a system to do so, the system that pretty much everyone uses today. In 2600 BC, workers from the pyramid construction site were compensated by the crown for their day's work. But they weren't the only ones. Farmers, midwives, real estate investors, scribes, priests, and commoners all had a good sense of basic math. And they were counting using a number system that we still use today. It's called the base 10 number system. In short, this number system is made of 10 units, from 0 to 9. Although this system would probably have been in use before the people from the Nubio-Kemetic civilization because of humans' 10 fingers, the Egyptians are the first to be recorded doing so, and they had a peculiar notation for it. And it goes as follows. Units are represented with straight ropes. Tens use heel bones. Hundreds use coiled ropes. Thousands the lotus flower. 10,000 the pointed finger. 100,000 the frog. And 1,000,000 the man on one knee. On the Edfu temple, we can see this inscription that shows the number 1,000,000, 300, and 30, 3,330. But as elegant and visually pleasing as it is, this system had a major flaw. As numbers got bigger, one would constantly have to invent new characters to represent the new large numbers, like billions. But more of an issue is the fact that symbols had to be repeated in multiples. So representing 89 requires us to draw 8 heel bones and draw 9 straight ropes. To simplify this, the Kemetu invented a whole other numerical notation. In the value for value model, if you feel that this channel has brought you and your loved ones some value, then I would be eternally grateful if you could consider returning that value in any way you can. For some, it comes in the form of channel or Patreon subscriptions, which go a long way. For others, it means sharing the videos in your social media and with your loved ones. The Egyptian number system evolved into hieratic form and was then adapted by the Phoenicians and many other ensuing civilizations. In the same way, the Western writing system was also adopted from the Kemetic writing, so too was their number system and basic mathematics. But one of the most interesting aspects of the Nubio-Kemetic civilization is that it had two forms of writing. In the most popular one, hieroglyphics, the Africans chose aesthetic over function. This is the form that is immediately recognizable by most, and the form that we just saw where numerals are broken down into signs for every digit and base tens, hundreds, 20s, and 200s use repetitions of the same symbols. This can lead to lengthy numerical representations for numbers like 9,998, which would look like this. For everyday use, Egyptians needed a much faster way to represent words, but also numbers. And for this, hieratic was used. And it is from this form that pretty much all major writing systems and number systems in the world derive. Our numbers today are called Arabic numerals, and are further attributed to India, who is said to have popularized the numerals and added the very important number 0. And yet, already in 1740 BC, more than 1,000 years before the Arabs, the Egyptians were already using the hieratic form of writing, along with its very different number system. As administrative and accounting texts were written on papyrus or ostraca, rather than being carved into hard stone, as were hieroglyphic texts, the vast majority of texts employing the Egyptian numeral system utilize the hieratic script. Instances of numerals written in hieratic can be found as far back as the early dynastic period. The Old Kingdom Abuser papyri are a particularly important corpus of texts that utilize hieratic numerals. Mathematician Carl Boyer proved 50 years ago that hieratic script used a different numeral system, using individual signs for the numbers 1 to 9, multiples of 10 from 10 to 90, the hundreds from 100 to 900, and the thousands from 1,000 to 9,000. A large number like 9,999 could thus be written with only 4 signs, combining the signs for 9,000, 900, 90, and 9, as opposed to 36 hieroglyphs. Boyer saw the new hieratic numerals as ciphered, mapping one number onto one Egyptian letter for the first time in human history. Greeks adopted the new system, mapping their counting numbers onto 2 of their alphabets, the Doric and Ionian. In fact, if you look at this table, which shows the hieratic numbers and their corresponding numerals today, you can still see the resemblance. See how the number 9 evolved from hieroglyphic form to its hieratic form before becoming modern. And that is a 4,000-year-old number system that is so ingenious that it has lasted till the present day. Pretty much most cultures in the world that use a base 10 numbering system can be traced back to the Kemetu. In our previous video, The Greatest Civilization in History, we saw how Africans spread technology and culture to the 4 corners of the globe in the remote past. As they fanned out, they also popularized their mathematics with their large number representation and their representation for the most basic of numbers, 0. By 1740 BCE, the Egyptians had a symbol for 0 in accounting texts. The symbol Nefer, meaning beautiful, was also used to indicate the base level in drawings of tombs and pyramids, and distances were measured relative to the baseline as being above or below this line. Interestingly, Nefer also means perfect. This name comes up often in Kemetu culture, such as the name Nefertiti. In her name you can see Nefer, Nefertiti meaning the beautiful woman has come, the perfect woman has come. But there was a civilization that was much older than the Egyptians who pioneered numeracy and arithmetic, and they did it with such excellence that it baffles mathematicians till this day. Found in 1950 by Belgian Jean de Heinzelin de Brocourt, in Central Africa, modern-day Congo, it represents one of the oldest found mathematical sieves. But unlike other prehistoric sieves, Ishango reveals to us that the region was inhabited by a people who had knowledge of advanced mathematics and practiced it often. The bone was adorned in one end with a pointed, sharp piece of quartz stone, indicating that it would have had an additional function of being a pen for a scribe or a student. Carbon dating shows that the bone dates back to 20,000 BC. That would be 14,000 years before Kemet started. The arrangement of unevenly apportioned incisions suggests that this artifact's primary utility was likely functional rather than ornamental. This configuration, dubbed the Ishango configuration, may have served as a framework for the development of a numerical system. The central column initiates with a set of 3 incisions, subsequently doubling to encompass 6. This process is reiterated with the figure 4, escalating to 8 incisions, then counteracted for the figure 10, which attenuates to 5 incisions. These numerical sequences appear not to be haphazard, but rather indicative of an elaborate comprehension of the mathematical concepts of duplication and halving. Thus, it's plausible that the bone artifact served as an early reference table of sorts, an early multiplication table that doubles as a tool to show relationships between prime numbers. Moreover, the quantity of incisions flanking the central column could suggest a more advanced numeracy capacity. The figures represented in both the left and right columns are exclusively odd numbers, namely 9, 11, 13, 17, 19, and 21. The left column specifically includes all prime numbers within the decadal range of 10 to 20, manifesting a prime quadruplet. Meanwhile, the right column encompasses numbers that result from the addition or subtraction of 1 from 10 or 20. The sum of the numerical values inscribed on each lateral column amounts to 60, with the central column yielding a sum of 48. Both of these summations are divisible by 12, reinforcing the premise that there is an underlying understanding of multiplication and division principles. All this aside, there is still one more discovery that the Ishango bone reveals about math in ancient Africa, and it is as impressive as its implications are startling. The Ishango bone shows that Africans knew of prime numbers back in 20,000 BC. This means that the creators of the Ishango bone knew about multiplication and division, but they also knew that not all numbers are divisible, and they clearly singled them out. This bone really hasn't received the proper media attention it deserves. It is without a doubt one of the crown jewels of human archaeology. And put it its proper context, meaning that these markings were probably made on a pen of a student more than 20,000 years ago, then the question arises, if this is what the student had as reference material, what did the teachers know that we haven't found yet? Historians have shown that the original people who formed the Nubio-Kemetic civilization came from Central, South, and West Africa. So the people from Ishango, adept in math, and the people from Western Sahara, with their cattle worship and expertise in mummification, come together as one people to form the beginnings of ancient Egypt, and from there they would go on to make the most recognizable proof of geometry and trigonometry ever: the pyramids. Yes, there are multiple manuscripts and papyri that show the level of math that the Africans in Kemet knew. But in building the pyramid, and through its incredible precision on so many levels, the Africans left proof of their knowledge in many areas of mathematics. This proof is so elegant that 4,500 years on, it still stands strong, even with its outer casing removed. And it begins with one of the most important numbers in the whole universe: pi. Erroneously attributed to be of Babylonian origin in 1680 BC, pi was known by the Egyptians well before the 1650 BC papyrus and well before Pythagoras and the Greeks. The Africans had calculated pi to the second decimal. Kemetu used pi for all sorts of calculations. It was so common to them that in the Rhind papyrus, its value is assumed as known. But it is important to note that the Rhind papyrus itself is confirmed to be a copy of a much older manuscript. How the Egyptians found pi, no one knows for certain. But it wasn't just pi that they discovered. They also discovered the Pythagorean theorem, more than 1,000 years before Pythagoras was born. How do we know? Each quadrant of the Great Pyramid is a perfect right triangle. And not just any right triangle, but a right triangle with proportions that resonate throughout nature and math. The golden ratio. If we take a cross-section through a pyramid, we get a triangle. If the pyramid is the Great Pyramid, we get the so-called Egyptian triangle. It is also called the Triangle of Price and the Kepler triangle. This triangle is special because it supposedly contains the golden ratio. In particular, the ratio of the slant height S to half the base B is said to be the golden ratio. The Pythagoras theorem states that the square of the longer side of a right triangle is equal to the sum of the square of the two other segments, as in this example of a 3-4-5 right triangle. Ancient Egyptians used this group of Pythagorean triples to measure out right angles. They would tie knots in a piece of rope to create 3, 4, and 5 equal spaces. 3 people would then hold each corner of the rope and form a right triangle. By carrying this rope tool across fields and construction sites, the ancient Egyptians could make sure everything was neat and orderly. But there is one more thing needed to proportionally distribute grain and beer to the pyramid builders according to their rank. A mathematical concept so important that it is used in all advanced scientific endeavors today. And the Africans were again the first to make use of it and popularize it, before the Greeks, the Babylonians, and the Arabs inherited it. Did you know that genetic studies show that ancient Egyptians are closely related to West, Central, and South Africans? See our other videos for details. Algebra. Now, the very name algebra is taken from the 9th century Arabic savant Al-Khwarizmi. Today, he is named as the father of algebra. Having access to ancient manuscripts from Greek and Kemet, Al-Khwarizmi devised a more formal set of rules to find an unknown value. These are pretty much the same rules we use today. His genius cannot be understated. So it is even more impressive that 3,000 years before him, the Africans from the Nubio-Kemetic civilization complex had devised the majority of the rules of algebra. Its main approach, which is to isolate and find the missing variable, but also a very Kemetic-like way of solving these problems. The method is called the method of false position. After isolating the variable you are looking for, you assign it a random value. That value is then used to see if it fits the problem. If it fails, we try to determine by how much we are off and use the difference to adjust our original assumption. This method was put on full display in the Rhind papyrus. In doing so, the Egyptians also formalized the concept of a variable. This is a very important concept of abstraction in mathematics and computer science, as it assigns a symbolic placeholder for a value by giving it a name. Kemetu would call it a heap or aha. Today, more often than not, we call it X. Here is a good example of how they would use it.
And so if the ancient Egyptians had a problem like this, like what you would see in the Rhind papyrus, it would actually be written as a sentence, and it would say, what is the value of heap if heap plus 1/8 of heap is 4? They would pick a false value. And the Egyptians understood these types of unit fractions with the 1 in the numerator, and so they knew that the best false value to pick for this would be an 8. So I'm going to take that 8 and I'm going to plug it in for each of the heaps. You might see why I picked 8. It should be pretty obvious because these are reciprocals. 1/8 times 8 is 1. So we would actually have 8 plus 1, which is 9. And we got 9. We meant to get 4. But we can use that to figure out what the right answer is. And so the question we have to ask ourselves is 9 times what number equals 4? We're basically trying to figure out how far away from the right answer we are. So this would be 9 times 4 over 9, and that equals 4. So basically, if you take our wrong answer and you multiply by 4/9, you get the right answer. Okay, so I'm going to call this the proportion value. So what they would do, we're basically done at this point, is they would take their proportion value and they would use it to scale the guess that they started out with and multiply, and they would get 32 over 9, which is the right answer.
To have figured this out in the 3rd millennium BC is simply brilliant. But you must have noticed that these algebraic formulas would have generated a lot of variables with numbers that are not whole. And here we again find another priceless discovery that the Nubio-Kemetu excelled at. And this mathematical concept was so important for them that it was found not just in their math, but in their art as well. Fractions. Eye of Horus itself is an artistic representation of the core fractions that the Egyptians used. In a sense, it is a perfect symbolism for the intersection of their artistic and scientific genius. Basic computation appeared in ancient Egypt as early as 2700 BCE. But you might not know that ancient Egyptians demanded that every fraction have 1 in the numerator. They were obsessed with writing any rational between 0 and 1 as a sum of such unit fractions. Such sums are called Egyptian fractions, and all numbers were expressed that way. Kemetu may not have had a floating point system, but their fraction system provided them with just as much flexibility to work with the number. The introduction of the decimal system by the Sumerian in the 4th century BC was a significant landmark in the notation of non-whole numbers. The genius was to realize that in between whole numbers, there exists an infinite number of values that should also be expressed. Their notation was an improvement on the Egyptians' concept of expressing these values with fractions. Today, decimal notation is a given in our society, and fractions have become ubiquitous, and their genius and usefulness drive the precision of our modern computing. In a society of precision, where even drawing of the human form had to follow precise proportions, fractions became ubiquitous, used from land disputes to allocations of funds and determination of ratio of material to use in the making of weapons, such as the khopesh. One of the ultimate expressions of the artistry of math was made by these Africans by encoding their sacred fractions into the Eye of Horus. In Nubio-Kemetic mythology, Thoth restored the Eye of Horus after Seth tore it out. He is said to have restored all his senses in order of importance: 1/2 with the nose, 1/4 for the sight, 1/8 for the thought, 1/16 for the hearing, 1 equal sign over 32 for the taste, and 1/64 for the touch. Thoth is said to have kept the remaining 1/64 to himself. The Eye of Horus evolved to represent eternal renewal and a return to harmony, and it also serves as a reminder to the scribes that this series of fractions is sacred and sums up to 1. Binary calculations. Before we return to the Egyptians and the Greeks, who inherited more than the foundations of their math from the Africans in Kemet, let us look at other ancient African traditions of calculations, namely how the Yoruba and the Ethiopians performed multiplications. The Yoruba civilization goes all the way back to the 7th century BC, where their predecessors, the Ile-Ife, founded the empire. As per Lounge's account, the Yoruba tongue possesses a particularly complex vigesimal numerical scheme. That is a counting system based on 20 digits instead of 10. It is one that employs addition, subtraction, and multiplication alike. The foundation of this tallying system is Ogun, signifying 20, or score. Each of the decades has its unique descriptor. Values from 1 to 4 are crafted by appending to these, while those from 5 to 9 are devised by subtracting from the subsequent decade. The peculiar decades are fabricated by taking 10 away from the upcoming even decade, akin to the Danish approach. Multiples also hold substantial importance in this number system. For instance, the digit 60 translates to Ogota in Yoruba, which quite literally stands for 3 20s, Ogun = 20, Itia = 3. Until the count of 30, Yoruba utilizes distinct forms of numerals for object tallying, derived from the tradition of counting cowries. The ancient Yoruba had a very interesting way of performing their multiplications. If you wanted to multiply 21 and 33 together, you would first multiply the first 2 digits of the number, then the last 2 digits, while leaving a placeholder in the middle. To find the value of the placeholder, you would multiply the outside numbers together and add it to the product of the inside number. Let's see it again in another example. First numbers and we get 12, then the last numbers we get 2, and now for the placeholder we multiply the outside numbers, we get 3, then the inside numbers we get 8. We add these together, 8 plus 3 equals 11. We write down 1 and carry over the 1 to the 12 that now becomes 13, for a total of 1312. Ingenious. And this stands as one of the many examples of the many indigenous African numeracy and calculation traditions. Another such example are the Ethiopians, who had a binary multiplication system almost identical to the one in ancient Egypt. Ethiopia, one of the oldest civilizations in history. First documented record of this empire goes back to the 10th century BC as Demant. However, it surely goes farther back as the people from the Nubio-Kemetic civilization reference rich empires south of Nubia. Ancient Ethiopians had a base 10 numerical system that is similar in function to the Kemetic hieratic numerals, and they used a binary method for their arithmetics. If you wanted to multiply 45 and 23, you would keep halting 45 until you get to 1, while simultaneously doubling 23 for the corresponding halved rows. When done, we would add all the odd rows to find the answer, in this case 1035. Incidentally, this is exactly how the Kemetu did their arithmetic. It is also exactly how computers today calculate, using binary code. How did our ancestors 5,000 years ago discover this universal way of performing arithmetics? How did Africans all over the continent discover principles that have become standards in our everyday lives? Well, it may have started by defining standards by establishing the first conventions. The standard measure. The first recorded official unit of distance measurement was the cubit in ancient Egypt. The cubit was measured by the distance between the tip of the elbow and the tip of the finger. Because this unit varied, Egyptians had a standard measure which they called the royal cubit. It was roughly 21 inches or 53 centimeters. This is what the new kingdom's standardized royal ruler looked like, and you could find on it other sub-measurements used by the Kemetu like the finger and the palm. Using the cubits and other standards of measurements like weights and volume, the Nubio-Kemetu were able to build all these grandiose statues and monuments. What really set our Africans' ancestors apart is their relentless obsession with perfection in measurement. You have all heard about the incredible precision and symmetry of the Great Pyramid, but there are countless examples of such extreme precision. Take, for example, the famous face of Pharaoh Ramses II. The symmetry is so precise it's exact to 1,000th of an inch. I mean, wow. It is pretty much machine-like in its dimensions. This is a topic we will explore further in future videos. The Kemetu weren't the only Africans that used standard measures. In fact, the ancient palace of the King of Benin, whose reconstruction you can see here, sports extreme levels of beauty, symmetry, and cohesion. It is said that the early British explorers who arrived in the Kingdom of Benin were in complete awe of the palace. Another example of this obsession with geometrical measurement perfection is in the establishment of standards used to draw people. There were conventions that dictated the proportions of the body parts in drawings, but these standards went even further. Stylistic conventions were imposed on artists in ancient Egypt. This is why this African art is so readily recognizable. Nubio-Kemetic math was so advanced and so influential in their time that the cubit, both its name and its use, became widespread in the ancient world. In fact, it was later found in Mesopotamia, Greece, and Rome, to name a few. But there are indications that the Africans may also have created, or at least have used, the meter. There are relationships between the cubit, the Great Pyramid, and the meter that are simply too hard to attribute to chance. If you hang a mass at the end of a 1-meter-long string and let it swing from a 30-degree angle, not only does it take 1 second for the pendulum to swing from one end to the next. Incidentally, this is how the meter was first standardized in 1840, but the distance traveled each swing is exactly that of a royal cubit. Does that mean that the ancient Egyptians knew of the meter? We cannot say for certain, but I will leave the links in the description to articles that go into details of the large number of quotes, coincidences, end quote, between the pyramid and the meter. When it comes to standards in mathematics, specifically geometry, there is one figure in ancient times that stands as a giant amongst all others, and that's the Greek math genius Euclid, who lived in 300 BC. Considered to be the father of geometry, he is said to have contributed the following in his seminal book, The Elements, the 5 Postulates, Pythagorean Theorem, Prime Number Theory, Systematic Proof, Geometric Algebra, Number Theory, Solid Geometry. These principles are still used, pretty much intact today. It is, however, interesting to know that the Africans had demonstrated the majority of these principles in the Rhind Papyrus and the Moscow Papyrus in 1850 and 1550 BC. To be clear, that is 1200 years at least before Euclid. Of course, those papyrus give us a good indication of the level of mathematical sophistication that the Kemetu had achieved, and they indirectly point to a tradition of mathematics where a form of scientific method was applied to achieve higher and higher knowledge. In volume 41 of the Rhind Papyrus, the Africans from the Nubio-Kemetic civilization show that they could solve problems related to volume of a cylinder. This implies that they knew pi, that they could calculate the area of a circle, but even further, they had a way to calculate volumes. So with just one of the problems of the Rhind Papyrus, we can see that students in Kemet already knew more than half of all the principles attributed to Euclid. In fact, from Thales to Pythagoras to Euclid and all other Greek math philosophers, we see a pattern, one where they produced their theorem after having spent time in Kemet, Africa, where they would have learned and become initiates to the Kemetic secret knowledge. And this is a fact that the Greeks themselves never hid. The mathematician Dr. Bruce Stewart, in no uncertain words, speaks to the true origin of Greek knowledge in his 2011 lecture.
Not what we think, but if you read what the Greeks said, they said they got everything from Egypt. They got all their knowledge from Egypt. Pythagoras spent 15 years in Egypt, and what did he have to do? He probably had to spend 5 years convincing them that he was worthy to get the knowledge that they had. Knowledge was guarded very closely because it was of tremendous value. You wouldn't give it to anybody. You would give it to somebody who was willing to shave his head and be a penitent for 5 years, and then you might start to tell him things. Okay? And the Greeks did this. Pythagoras did this. Other Greeks did this. And they said that they got all their knowledge from the Egyptians. Now, when did we come up with the idea that the Greeks created everything from scratch? Well, believe it or not, it happened in the 18th and 19th century. And in the 18th and 19th century, it was decided that it was just not appropriate for all this knowledge to come from an African country.
From the very orderly, Africans also delved deep into the mysteries of what at first look seems disorderly. At least it did for the untrained eyes and early European explorers. All over Africa, cities and royal palaces used very recurrent patterns called fractals. A fractal is a complex geometric shape that can be split into parts, each of which is a reduced-scale copy of the whole. Fractals are typically self-similar patterns, meaning they are scale-invariant and can be magnified indefinitely without losing their complex structure. Inside the Logon-Berny Palace in Cameroon, we can see how the alleyways of the palace form an ever-tightening pattern, and Africans excelled at using fractals in their architecture and in their art. Today, fractals have become essentials to our modern society, from computer graphics to data compression, networking, and identification of patterns in financial markets. In his book, African Fractals, Ron Eglash shows sumptuous examples of fractals in African architecture and art. Here are some striking examples of its usage in South Africa, taken from his book. As we can see, the mathematical expressions of the Africans became so advanced that they transcended paper notations. We saw how they showed up on temple walls, on statues, on fractal recursive designs. But there is another art form that is very akin to math that the Kemetu also loved, and they were the first to standardize its notation, and that is musical notation. Here again we will see how innovative the Kemetu were. If you Google, who were the first to write down music, what you will see are answers that point to the Greeks being the pioneers of musical notation, and some references to the Babylonians. And yet, Plato himself attested that the Africans were already using musical notes back in his days. He said, and I quote, "Postures and tunes that are harmonically pleasing, these they prescribed in detail and posted up in the temples." End quote. Furthermore, the accomplished musicologist François Fétis stated that, quote, "I have not the least doubt that this musical notation used in ecclesiastical music by the modern Greeks belonged to ancient Egypt." End quote. We can see from these papyrus how practical and intuitive the Egyptian musical notations were. What I find particularly interesting is how the colors represent different notes, and the size of the dot represents how loud the note should be played. There are suggested transpositions of Egyptian musical notations to modern musical notes. You can see how C equals yellow and D is purple. And what you are hearing right now is a piece of reconstructed ancient Kemetu music from 1400 BC on the lyre. From the music of the kings to the dance of the celestial bodies in the skies, string theory has become one of the most important interpretations of the laws of the universe. So when physicist James Gates discovered recurring codes in the laws that dictate behaviors of every subatomic element in the universe, he rightly so named it after the Ashanti writing hieroglyphs, Adinkras. This is one of the first theories that showed that our universe may very well be a simulation. When it comes to the contribution of the African to mathematics, it is hard to do this subject justice in one video. Suffice to say that the contributions of the Africans were not only foundational, but also consequential to the existence and development of the science. As you can see from the examples on the screen, the tradition continued well after antiquity, into the Middle Ages and pre-colonial era, in all parts of Africa and wherever Africans were. Too many to cite, from Imhotep to Dorothy Vaughan, the human computer who computed the trajectories of rockets for NASA in its early days, Africans have always excelled at mathematics. The many mathematical and astronomical manuscripts in the library of Timbuktu also attest to this. The ultimate expression of perfection in mastery in math is really in mathematics, when its various concepts become abstract and then blend to form a new perspective of reality. And no other art form exemplifies this more than Cubism, the art form popularized by Picasso, who himself took it from the Africans. Well, at least click the link and support Without History on YouTube or Patreon. Huge thanks for all the supporters who made this possible.
Jumbo on this one.
found the video informative, make sure to share it on your social media. What you are looking at are various masks from Africa and the Caribbean. See if you can spot where each one comes from. Join us and see how those who are said to be without history birthed civilization itself.